So, as always, during these discussions, I take the questions that people submit first and try to discuss those. And if there are no questions, and um, then I kind of owe a few minutes of discussion on, I guess, the topic of my choice related to one of the physical science online courses. Specifically, I try to make it something related to this week, right? So we're in week 7. Week 7 is the course on, or is the chapter on optics. In the lecture, that means we're looking at ray diagrams. In the lab, we're actually also doing an optics lab, and it is basically finding the focal length of a lens. So today's topic of discussion is the ray diagrams for a lens, and this is mostly valid for the lecture, but it is also valid to some extent for the lab because it kind of gives you context for what your experiment is doing. The main purpose of a ray diagram is you're drawing light rays. So ray diagram is to sort of sketch or draw light rays to, let's say, to make sense of an image or to describe an image. And hey, if it is to scale, we're trying to describe an image. And then a note that we should say is if drawn to scale. So if you draw everything to scale, then image will be well defined. And by that, I mean you can find where and how big or what magnification. And oops, that's not very well written. For what it's worth, it helps to use a ruler and not just to draw to scale, but also to draw nice straight lines. And in fact, actually on this, there's a ruler tool, but I don't actually intend to use that too much on here. I want to say that in this program, I don't know if in this program I have a simple straight line tool. So I may not be drawing especially much to scale. But if you're drawing this with pen and paper, you can use a ruler to get your lines nice and straight. Unfortunately, because of the setup I have, and most of you don't see this setup, it's just like a little drawing tablet and a pen. So, these are not going to be my best of all diagrams. On a chalkboard, like a real chalkboard where I can put a ruler up or a meter stick up and draw nice straight lines, this will look very nice. This right here, not sure if I can add straight lines. May have to customize my toolbar from what I usually use. Yeah, that's a no-go. So this program I'm using, PowerPoint, is very good for 99% of my notes. Today is basically the other 1%. Here, for example, I can put a straight edge on here, but this is not necessarily going to be the same as actually having a straight edge present, if you understand what I'm saying. So keep those caveats in mind. So first, before we draw this, consider two types of lens. So broadly, you have convex, which are focusing lenses. Usually you draw them like this, or maybe you draw one side curved out and the other side straight like this, some such thing. And then you have concave or defocusing. So those usually are drawn like this, or you can draw them with one straight side and one curved side. Another thing to note is that focal length is usually positive. And then for these, the focal length is negative. Okay. For what it's worth, a very simple ray diagram for each of these can be drawn to find focal length. So can draw rays to define focus and hence focal length. So let's do an example of what that would look like. So right here, we're going to draw for ourselves a simple lens. And there's actually two lines that we need to sort of draw when using these lenses. One is what's called the principal axis. And then the other one is one that I kind of add for my own benefit, is sort of my ray axis or my lens axis. And what that's for is, instead of trying to figure out the exact way that light bends at each point on the lens, it's easier to treat it as if light hits this axis and then bends at this axis. So once we've done that, the next thing you have to do is basically just draw your rays. And your rays should all be parallel to your principal axis. So here's a ray. Right here's a ray. These are meant to be parallel. Again, unsteady hand and imperfect drawing surface. So once I've got these drawn, basically they're coming in straight like this. So these are my rays. Essentially, they're going to bend at this point here, and they're going to bend, in such a way that they cross the axis at some point. So here's one of them. This one right here is one. This right here crosses. This right here crosses even more steeply. And then likewise, these ones will also cross. And they all, cross at the same point. And it's just not a very good surface. Everything crosses at the exact same point. And this point where they have all crossed, this common crossing point right here, is the focal point. And we usually label it just with a capital F. The same distance away, but on the other side, there's a second focal point, because in principle, we could send the light from the other direction and it would all cross here instead. So sometimes we label this second focal point as F prime. And the distances, this right here is lowercase f, the focal length. This right here is lowercase f, the focal length. So basically to your focal point. Horrible. Okay, so f is focal length. We could likewise do this for the other kind the defocusing lens. Here again is my principal axis. And basically you would draw your rays. Oops, I forgot my lens axis. You draw your rays coming in like so. And then instead of bending towards the principal axis, they actually hit this and bend away. So this one would go off like this. This one would go off like this. This one's going to bend off at an even more steep angle. This one bends off at a more steep angle. And so basically what you do is you draw a dashed line that is a continuation of each of these lines. And where those dashed lines cross your principal axis, that's where the focal point is. So this right here is my virtual focus. This is my focal point F. Same distance away on the other side is F prime. And then this length right here is again my focal length. Note that in this case, the focal length is negative, so I could put a negative in front of the F here if I wanted to. Okay, so now that we've established that that's where the focus is, for the lab, what you're basically doing is you're taking sunlight, and by the time sunlight gets to the Earth, it basically is all collimated like this. So all of the rays are more or less parallel to each other. And therefore, if they go through a lens and all focus at the same point, that point will be the focal point for that lens. Excuse me. So that's the focal point for that lens. In the case of a focusing lens, that focal point is also the point where the light is sort of most concentrated and therefore brightest. And so if you hold a piece of paper at that focal point for a big enough lens, you might catch the piece of paper on fire, like you'll burn a hole through it. So that's one way of finding where's the focal point, is how far away from the lens do you have to hold the paper before it's on fire. And in fact, there should be a range of distances. You know, maybe this is where the paper starts burning and this is where it stops burning. So your focal point should be about midway between those two locations. Okay. So now let's consider some scenarios for drawing for the image formation. So basically what you do is to find where an image is, you draw your lens, you draw your principal axis. Oops, curved. You put your focal point and your opposite side focal point. So F and F prime. And then you put your object. Let's actually put our object, just for the fun of it, in green. So maybe I happen to choose this location right here to be my object. Now, the easiest object to deal with is an arrow. And what you do is you draw a ray, and the ray always has to go through the top of the arrow. So all the rays that I'm going to draw are going to go through the top of this arrow. Now, they are defined conveniently. And by conveniently, I mean, for example, maybe we choose this to be one of our rays. This is convenient because it's parallel to this principal axis. Now, since it's parallel to this principal axis, it's not distinguishable from any of these rays here. That means that it's going to have to go through the focal point. And I mislabeled the focal point and the other focal point. They should have been like this. Somebody came in and distracted me as I was drawing this. So this right here has to go through the focus. Okay. So let's call this one ray number 1. Starts at the tip of the arrow, parallel to the axis, goes through focal point. Okay, that's ray 1. Ray number 2 needs to start from basically the F prime focal point and go through the top of my object. That's going to hit this axis right here, and it's going to deflect in such a way that it's parallel to the principal axis. So this is now parallel to my principal axis. Okay. And you'll notice that these two rays don't really intersect anywhere. They in fact are diverging. So what I do is I, take this guy goes through here. I basically just backtrack with a dashed line like so. And I have to backtrack this one with a dashed line like so. Where these two dashed lines intersect, that's where my image is being formed. And I'm going to draw the image in gray. Okay. So I may actually have made this a little too steep, by the way, but this is my image. This is my object. All right, so what can I say about my image? In this case, the arrow points the same way for the image and the object, so it's upright. There we go. It is virtual. That means we had to draw dashed lines to intersect. And it's magnified larger than object. Okay. And it's also farther away. Specifically farther away from the lens than the object. And that's basically what we can say from this ray diagram. We could say more if we had better tools, like a more straight line drawing. Let's do another one. Okay. Let's do one where this time my lens, oops, is here like this, with again my virtual axis like this, my principal axis is right here. But this time, instead of having the object between the focal point and the lens, I'll put the object farther away than the focal point. Okay, so here's my object right here. Again, my first ray, give me just a sec. Again, my first ray will be parallel to the principal axis, starting from the tip of my object. and it will deflect in such a way that it will go through the focus. My second ray, I'm going to label this as, as 1. My second ray will go through the focus from the tip of the arrowhead, hit the mirror, hit the lens, and deflect so that it is parallel to my principal axis. So here's ray number 2. Well, where the two have met, because they do intersect, that's where my image will be formed. So here's my image. And this is my object. Now, on the previous one, I did not draw a third ray. You can, in fact, draw a third ray as a double check. Basically, your third ray starts off at the top of the arrow and goes through the lens right where the principal axis hits the lens axis. And that one just continues straight. I'm not having very good luck getting this drawn right, but basically, if it passes through the same point, then you've double checked it. I don't really think it's going to be a very good double check here because of the fact that I can't draw very straight with the pad that I have. But let's describe what this image has done. So image is inverted. So arrow points down or opposite direction from the original object arrow. This one's up, this one's down. It is real. No dashed lines needed. For what it's worth in the lab when you're doing this, if you get a real image of the candle, it means that you'll see the candle show up on the piece of paper or card or whatever you're using to project onto. With a virtual image, you won't see it. And I think in this thing's case, it may also be larger than the object, but without, a more straight line drawing, the magnification is inconclusive. It was very bizarre. I'll call it magnified with a question mark. And it actually depends upon how far away you put the object versus the focal length. If it's very, very far away, if the object distance is great, like 10 or 20 times the focal length, then the image will actually be quite small. So it will be demagnified or miniaturized. Okay, that's all I'm going to have time to do today. This is more than the 15 minutes that I promised when nobody shows up, and nobody shows up. So I'm gonna stop here because I have people in my on-campus classes who keep showing up every 3 minutes because they all have questions since they've got their final exams coming up. So this will be the end of today's. Hopefully somebody watches it and gets something out of it. So that's it. Thank you and goodbye.